the next topic, that is potential energy of a system of charges. Suppose we think about a system of charges as shown in the figure. Now we have to calculate the total work done for the assembly of this particular system. And we know this thing, that total work done will be stored in it in the form of potential energy. So for this particular assembly, first we think about charge Q1. Suppose charge Q1 is brought from infinity to point 1 having position vector R1. But when we bring charge Q1, at that time there is no any other charge. So we can say there is no electric field. So when there is no electric field, then work done to bring this charge Q1 from infinity to point 1, that work done, that is equal to 0. So charge Q1 is placed at point 1 having position vector R1. In this, the work done, that is 0. Now when charge Q1 is placed at position 1, then due to charge Q1, the electrostatic potential at any point P, that is given by V1 equal to 1 upon 4 pi epsilon 0 Q1 upon R1P, where R1P, that is the distance between 1 and point P. Okay. Now next, suppose we bring charge Q2 from infinity to point 2 having position vector R2. So here the total work done, that is charge Q2 into potential of charge Q1. So we can write the work done in that process, that is 1 upon 4 pi epsilon 0 Q1 Q2 upon R12, where R12, that is the distance between point 1 and 2. Clear? Now this total work done to prepare the assembly of these two charges Q1 and Q2, that will be stored in it in the form of potential energy. So we can say this thing, the potential energy of a system of two charges Q1 and Q2, that is given by U equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R12. Similarly, now we can calculate the potential energy of a system of three charges. Okay. Now suppose here, if we think about any third point where we want to place charge Q3, then at that particular point there will be the potential of charge Q1 as well as potential of charge Q2. So the potential of Q1 at Q3, that is 1 upon 4 pi epsilon 0 Q1 upon R13. Similarly, potential of charge Q2 at 3, that is 1 upon 4 pi epsilon 0 Q2 upon R23. So we can say the resultant potential at point 3 due to charge Q1 and charge Q2, that is V12 equal to 1 upon 4 pi epsilon 0 into Q1 upon R13 plus Q2 upon R23. Now if we bring charge Q3 from infinity to this particular point 3, then the total work done, that is Q3 into the potential at that particular point. So we can write W3, that is Q3 into potential due to 1 and 2 at point 3 having position vector R3. So we can write 1 upon 4 pi epsilon 0 Q1 Q3 upon R13 plus Q2 Q3 upon R23. And now this total work done to assemble the system of three charges that will be stored in it in the form of potential energy. So here the total work done in assembling the system of three charges, that is W1 plus W2 plus W3. W1 that is 0. So 0, then W2 that we calculated 1 upon 4 pi epsilon 0 Q1 Q2 upon R12 plus W3 that is this one 1 upon 4 pi epsilon 0 Q1 Q3 upon R13 plus Q2 Q3 upon R23. So here the resultant work done to assemble the system of three charges which is stored in it in the form of potential energy. So we can say now the potential energy of a system of three charges Q1, Q2 and Q3, that is U equal to 1 upon 4 pi epsilon 0, that is taken common here. So Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 upon R23. So here now in general for a system of n charges we can write the equation for the potential energy of a system of n charges, that is U equal to 1 upon 4 pi epsilon 0 sigma I equal to 1 I less than j up to n qi qj upon rij, or we can write that is equal to k sigma I equal to 1 I is less than j up to n qi qj upon rij.